Hey guys, how's it going? Mr. Mitchell here. In this video we're going to recap resistance, so let's get started. Now just like current and potential difference, we also saw resistance in the National 5 electricity topic, and it also appears in the higher physics electricity topic, so this will act as a bit of a recap from National 5. So what is resistance first of all? Well, remember resistance is in opposition to current flow, so if current is flowing in one direction around your circuit, resistance will act against that current flow to stop it from flowing. We therefore say the greater the resistance, the smaller the current flow, so they're almost like opposites. And the units of resistance, remember, is ohms, with this Greek letter omega as the symbol. And you should also remember the device we can use in a circuit to measure the resistance of a component. So this is called an ohmmeter and has the circuit symbol of this thing here. So it's a big circle with the Greek letter omega inside it to show you the unit of resistance there. At National 5 we also saw that the resistance of a material depends on 4 different things. So it depends on the type of the material. So we say that metals, or more generally conductors, have a low resistance, and that's to allow more current to pass through them, whereas insulators will have a high resistance. The resistance will also depend on the length of the material, where longer materials will give a higher resistance to the flow of current, and that's because there's further to travel through the material for the electrons. And that means that shorter materials will have a lower resistance. Resistance also depends on the thickness of the material, where we say that a thinner material gives a higher resistance. And that's because if you imagine a thinner material having less space for the electrons to move through, that is going to cause more resistance for those electrons to try and move through the smaller space. So it must be a higher resistance. And that means a thicker material will have a lower resistance. And the last thing that resistance depends on is the temperature of the material. So we say that the higher the temperature, the higher the resistance. And this is due to the increased movement of the molecules that make up the material. So if the molecules are moving about more and colliding with these electrons that are trying to move through the material, then this will pose a higher resistance to that flow of electrons. So we could therefore say that a lower temperature material will have a lower resistance. Not only can we find a resistor in a circuit, we can also find a variable resistor. And remember, this word variable just means to change something. So this means a resistor that can change its resistance. So we say that in a circuit, a variable resistor is used to allow the current to be altered by increasing or decreasing the resistance. For example, a dimmer switch for lights is a variable resistor that can be used to change the brightness of the lights. We also have a volume control, for example, on speakers or a stereo system, where you can increase or decrease the current flow to change the volume of the sound that you hear. And there's many other examples, such as a thermostat to control your heating and the temperature controls on a hairdryer. Lastly, it shows here the circuit symbols for a resistor and a variable resistor that again you might remember from National 5 level. So over on the left we've got the resistor, which is basically just a rectangle, a box, and then on the right hand side we've got our box or rectangle with a diagonal arrow going through it. That's all for this video folks, I hope you find it useful. If you did, give it one of these, subscribe to the channel, and I'll see you in the next one. Take care.